Okay, thanks everyone. Sorry about that. Series of issues. Okay, so I'm going to be talking. So first of all, thank you everyone for coming. It's good to see a lot of you. A lot of you I haven't seen in a while, so this is very nice. So I'm going to be talking about typicality, and in particular, a principle that links facts about what's typical to facts about what's rational to believe. So this is a rationality principle that runs from typicality facts to what you should and should not think about various things. I call it the principle. So to start, I'm just going to summarize some basics. I'm going to explain, kind of give a first pass explanation for what typicality is. I'm going to then I'm going to talk about a little bit about what evidence is, and then I'm going to talk about one of the most complicated features of the principle, the notion of inadmissibility, what it is for one proposition to be admissible or inadmissible with respect to another, which is going to help this principle avoid some problems that have been raised in the literature for principles in the same spirit as this one. And that's going to be the third part of the talk, showing how the principle avoids this sort of problem. And I'll also there briefly mention other principles that I have endorsed, many of the people who are here today have endorsed, that are all kind of very much similar in spirit and sympathetic to the basic idea of the typical principle. Finally, I'm going to spend a little bit of time talking about the relationship between the typical principle and another much more well-known principle of rationality called the principle, which is a link, which establishes a link between facts about chance and rational credences. So whereas the typical principle establishes a link between facts about what's typical and rational beliefs, principle does analogously, but for chances and credences. I'm going to talk about how the typical principle actually implies a big chunk of the principle. I'll explain a little bit more precisely what I mean by that later on. Nevertheless, how people who kind of thought that the full force of these principles was required, that rationality really required the entire principle or the entire typical principle, will have reason to think that both principles should be endorsed. So even though I'm going to say a lot of things that suggest that the typical principle is the more sort of fundamental principle of rationality because of its link, because it implies the verdicts of the principle, I'm also ultimately going to suggest that at least certain types of theories, certain prominent theories of rationality will require both. Okay, so the setup first. So there are a lot of different analyses of typicality, but they all share the sort of following basic core. Something is typical just in case nearly all things of a certain sort are a certain way. So gases with thus and so initial microstate typically expand to fill their container. So gas that starts out on the left side, it has a macro state corresponding to evenly filling the left side of the container, typically expands when a barrier is removed to fill the container. What that means is in the vast majority of, say, microstates compatible with that initial macro state, the vast majority of those initial microstates are on trajectories that evolve into an equilibrium state for the gas. That's just an example from statistical mechanics of what it is to say that a certain sort of behavior is typical for gases in boxes. I'm going to today use a particular regimentation of typicality talk that is, I think, especially well conducive to formulating rationality principles. This is something that actually in a paper that Harry Crane and I wrote up a bit ago. This is a formalism that allows you to, that takes typicality to be a sentential operator, a one-place sentential operator that applies to sentences to yield a sentence whose meaning intuitively is that the sentence that the operator is applied to is true in almost all the contextually relevant possibilities. Anyway, the details of that get pretty formal. Happy to talk about it in the Q&A, but here's the basic idea. Let P be some proposition. Say that proposition P is typically true in some given set of possible worlds gamma, if and only if gamma sub P is nearly as big as gamma itself is, where gamma sub P is the set of all worlds in gamma at which P holds. So in other words, what it is for P to be typical in capital gamma is just for the P worlds to take up almost as much or as much of almost all or all of gamma itself. And what's meant by nearly as big as, there are many different ways to precisify that, using measures, using cardinalities, using semi-measures. There's a lot of options, but the intuitive idea is always the same. You have some way of quantifying size, and what it is for a proposition to be typically true in a set of possible worlds is for your size quantifying thing to say that the set of possibilities where P is true is about as big as the background set gamma is. Quick notational note, in what follows, I'm going to use this, this symbol tip sub gamma of P. That's just shorthand for the proposition that P is typically true in this set of possible worlds gamma. Okay, so that's typicality. Now evidence. So evidence is basically what agents use to form rational beliefs about the world. Your evidence consists of, on a lot of accounts of what evidence is, all the propositions that you know. So you know that you're at a talk right now. That's in your evidence. You know that today is November 15th. That's in your evidence. Your total evidence is then, just think of it as a big conjunction of all the propositions that you know, all the propositions that comprise your evidence. So these two notions, evidence and total evidence, are I think pretty straightforward and pretty familiar. Should be pretty familiar to us, but yeah, I just wanted to mention them quickly because they will play a role in the principle to come. Okay, now for the trickiest thing. In the literature on the principle, there has been a lot of discussion of the notion of inadmissibility. It's interesting that those discussions of the notion of admissibility are always sort of focused on the principle. It's interesting that is an interesting feature of the literature, because the kind of basic idea of an inadmissible proposition is much more general than that literature would lead you to suggest. So what I'm going to do now is present a kind of big picture characterization of what this notion you may have heard of inadmissibility is. And then I'm going to present a precisification of it based on some stuff by Chris Meacham and Jack Spencer. And then I'm going to gesture at some other things about it. But this is all just to kind of hopefully take something that you might have heard about with respect to one rationality principle, the principle, explain how it's more general than it might have initially been presented to be, and then adapt that more general thing to the typical principle that I'm going to propose in a minute. Okay, so that's the plan for the next several slides. So here's the general notion of it inadmissibility. We've got a bunch of principles of rationality, and these principles of rationality purport to be good guides to the rational stochastic states regarding various propositions. Okay, but sometimes these principles are not good guides. There are some agents who have certain propositions in their evidence, such that because those agents have those propositions in their evidence, the principle in question is no longer a good guide to what the rational stochastic states are. In other words, to put it the way it's put on the slide, if a given principle is indeed a good guide to the rational stochastic states for some agent regarding some given proposition P, then certain other propositions cannot be in that agent in your evidence. And those certain other propositions, the ones which render some given principle a poor guide to rationality, are said to be inadmissible with respect to P. That's the general idea of inadmissibility. Well, let me give you a quick example, sort of a stock example of what that means in the context of a principle like the principal principle. So suppose you're going to flip a fair coin. And suppose that you know that the coin is fair. So you know, and it's part of your evidence, that the chance of this fair coin landing heads is 1/2. Now, the principal principle says because of that, principal principle says in a very, very rough sense, I'm going to talk about a more precise version of the principal principle later on. But for now, for present purposes, first pass characterization of the principal principle, it says, because you know that the chance of the coin landing heads is 1/2, your credence in the coin landing heads should be 1/2 as well. So the principal principle is acting as a guide here to what the rational credence is, that particular sort of doxastic state, in a particular proposition, the coin lands heads, are. The principal principle is acting as a rationality guide, a rational principle that guides the rational credences in that particular proposition. But now suppose that God has just told you, and you know that God has told you, it was very clear that someone came down from heaven and told you that the outcome of this future flip was going to be whatever. Say that it was going to be tails. Or suppose you looked in a crystal ball and you saw that that was going to be the outcome. Doesn't matter how you got the information. Suppose you learn by some source that is clearly infallible to you, or something like that, that in fact the coin is going to land tails. So now that proposition, the coin lands tails, is part of your evidence. Because that proposition is part of your evidence, the principal principle is no longer a good guide to what the rational credence is in the proposition the coin lands heads are. So that proposition, the coin lands tails, is rendering the principal principle kind of inapplicable, or a crummy principle for the rational facts of the matter. Because of that, in the literature, people say that the proposition you learned, that the coin lands or will land tails, is inadmissible with respect to the proposition the coin lands heads, or excuse me, the chance of the coin landing heads is 1/2. So that's an example of this is an example of a situation where you have an inadmissible proposition in your evidence. So similar things can happen with typicality. There are possibilities, remote ones for sure, but they are there, where you can know something that kind of undermines the very natural relationship that I think a lot of people on this call are going to be sympathetic to, between A, typicality facts, and B, facts about what is and is not rational to believe. There are propositions you could come to know that would undermine that relationship, that rational guiding relationship. That's what I'm going to do next. I'm going to give you a characterization of what it is for that relationship to be undermined. A characterization of what it is for one proposition to be inadmissible with respect to another, but this time not vis-a-vis how these propositions are figuring in the principal principle, but rather vis-a-vis how these propositions are going to figure shortly in the typical principle. Okay, so there are a couple different characterizations of inadmissibility in the literature. And I would be, so let me say two things. One, at this point in this project, I would be happy with any of them. I think they just generate different and interestingly different versions of the typical principle. Two, I think this is an area that should be open for future research and should get more attention. What sorts of, because basically what's going on here is we want to come up with a good constraint on when typicality, or characterization of when typicality facts are not good guides to rational belief. And this is one proposal drawn from the literature. There are other proposals you could draw from the literature. There are surely proposals that are not equivalent to any of the proposals, or that similar to any of the proposals, proposed accounts of inadmissibility designed for the principal principle in the literature. And I think all of these deserve to be explored. And it's one of the like really interesting, exciting areas of work on the kind of uh, capacity that typicality facts have to guide rational belief. This is one of the like interesting open areas of research there. Okay, so here's the characterization of what it is to be inadmissible. So in what follows, I'm going to say the proposition Q is admissible with respect to that proposition, so the proposition that P is typical in gamma, just in case the conjunction Q and P is typical in gamma is logically equivalent to a disjunction of law history conjunctions. And if not, I'm going to say that Q is inadmissible with respect to the fact that P is typical in gamma. Okay, so let me just quickly clarify the notions, the notion of a law history conjunction. First, a law proposition is just a proposition which specifies a physical law. Second, a history proposition is just a proposition which specifies everything that happens across all of time in some given possible world. And then finally, so a law history conjunction is just a conjunction of a law proposition and a history proposition. So what this account of admissibility is saying is the following: for Q to be admissible with respect to the fact that P is typically true in gamma, is just for it to be the case that the conjunction formed from Q and that typicality fact is logically equivalent to a big disjunction that reads like this. Either this is the law and the history is like this, or this other thing is the law or a law and the history goes like that, or this third thing is a law and the history goes this third way, or and so on and so on and so on. So that's what this is saying inadmissibility or admissibility is. It's logical equivalence to some proposition like that. Why would we think that that's an intuitively good characterization of inadmissibility and admissibility? Basically, the reason is the same reason that these people who work on the literature in admissibility have given. The reason is this: intuitively, in order for a proposition Q to be admissible with respect to the fact that some other fact, like the fact that P typically obtains in gamma, the following needs to be the case. Q, along with that typicality fact, does not imply anything more than is implied by the laws plus the possible histories of the world. So the laws plus the possible histories, in order for Q to be admissible with respect to the fact that P is typical in gamma, Q conjoined with that typicality fact can't like go beyond what the laws and the possible histories tell you.
Admissibility is admissibility at a time.
So right now, no. Right now, I'm not doing it at a time because so this is one of the differences between this definition of admissibility and the definition from the principle. Chances evolve over time. However, the fact that a gas typically expands to fill its container, that fact does not evolve over time. So that's why you don't get these kinds of time relativizations in the notion of admissibility that's I'm using here.
So history is the history of the whole.
Yeah, so history is not up to a time, but it's like the entire, the gas's whole trajectory is the idea. Yeah, good, thanks. So to summarize the intuitive idea, inadmissible propositions say something more plus than laws and histories together say, whereas admissible ones don't. So, for example, let P be the proposition that this gas in a box quickly evolves to equilibrium, and let gamma be the set of all possible trajectories of the gas, and let Q be the proposition that the gas began in thus and so initial macro state. Then plausibly, this conjunction is logically equivalent to a disjunction of law history conjunctions. Why plausibly? I mean, there are a couple different arguments you could give. The one I favor is, I actually think the facts about what is typical are often laws. They are just nomological. They follow from the laws plus some other sort of nomological assumptions. So tips of gamma P is a law. And then Q the proposition that the gas began and thus and so initial macro state is itself logically equivalent to a big disjunction of a bunch of possible histories. The gas began in this microstate or this microstate or this one, going over all the microstates in the macro state in question. So that conjunction of Q and the typicality fact ends up being a logically equivalent to a disjunction of conjunctions of the law tip sub gamma P and the history sort of uniquely picked out by one of the microstates in the initial macro state. Okay, so this would imply that Q is admissible with respect to the fact that P is typical in gamma.
So this junction could include things that aren't typical. Histories that aren't typical.
Yeah, that's right. In fact, every history is atypical because it only happens once in gamma. Yeah.
My question might be similar to Glenn's. I'm not sure, but let me try to ask it. What's the relationship between Q typicality gamma P and that disjunction of things? It seems like Q conjunction typicality gamma P should be one of those things that are in the law history conjunction.
It just has to be logically equivalent to one of the disjunctions of law history conjunctions. Yeah. So, and by logical equivalence is just my more techie way of saying it doesn't say anything more or less than would be said by a big disjunction of the form. This is the law and this is what happens in the world, or this is the law and this is what happens, or so.
So that is to say that you have a bunch of law history conjunctions and you take the disjunction of that, and if it just so happens that this whole thing is equivalent of saying Q and typicality of gamma P,
Yeah,
then you would say that Q is admissible to
Exactly.
typicality of gamma P
with respect to that.
with
Yeah.
respect to that.
Yeah.
And then you're saying that it should be, I guess, obvious what Q and P respectively should come out once you have a fixed or a given set of disjunctions, because the P is typically the law and the Q is typically the history. Is
Oh.
that
So the P and Q are schematic here. So P could be, for example, in this example, P is just the proposition, the gas evolves quickly to equilibrium.
Mhm.
And it evolves quickly, meaning in some small amount of time. You can just pick. So it's not a law because it's about a specific object, the gas.
At a particular time.
Yeah.
At a particular time.
Yeah, sure. From time 0 to time 3, the gas reaches equilibrium, something like that.
So why could the law be a law that says nothing? I mean, in that disjunction, is there a law that makes no statement?
Are you asking what could this disjunction be that would be equivalent to the conjunction? Is that what you're asking?
Well, I'm wondering why laws have to be involved. Why? I don't see how you get a law necessarily involved in saying, making this typicality statement and saying that this is going to happen. Why does a law have to be involved? Is one of the possible disjunctions one where the law says nothing?
I suppose it could like a tautological law, just like a sort of vacuous. It could be, but more intuitively, the reason that there's this law or requirement in the big disjunction conjunctions is because I'm most interested in situations where there's a typicality fact that is in some important way related to the laws. So that could be important way related to, could mean just follows from, like the fact that gases typically expand just follows from the laws, maybe plus some assumptions about how big sets are. Or it could be something else. It could be like it literally is a law. Or it could be maybe there's some other super tight relationship between the laws in question and the typicality facts. But anyway, that's kind of what's going on here, and that's why there's this requirement that Q and tip P is logically equivalent to a disjunction of conjunctions that specify ways the world could be and also the laws. It's the same thing in the principle. So in the principle, the idea is what would render the principle like no longer a good guide to what's rational? If someone's given you information that goes beyond what the laws say intuitively. God comes down and tells you something more than you would know if you knew the laws. And it's the idea here.
Shouldn't keep asking questions.
No.
I don't let you too much, but I'm puzzled by the particularity of P when you were first talking about this some gamma of P. I was thinking P is a sort of generic statement, but here P seems to be
It's a proposition.
it's a proposition that is true or false.
Yeah, that's right. It's a proposition that at each world in gamma has a definite truth value, one of the two, either true or false.
So
Yeah. So like on some microstates,
the proposition might be that I ask Barry for another.
right? So
Okay.
and let's let gamma be the set of all possible worlds. Let P be the proposition. Glenn asks Barry for another cup of tea.
Typically, okay.
Okay, so that's a different P. Okay, so now P is the proposition. Barry gets Glenn a cup of tea. Now we look at all the microstates that are compatible. But so now we have our set gamma. So that could be something like if you've got like a Mentaculous picture, it's like specifies all the the whole macro state right now. And then we just look at all the trajectories, the microstates in that macrostate that are going to lead to Barry getting Glenn a second cup of tea. Suppose there's just some fact about how many of those trajectories have that property. And I mean, I'm guessing it's not maybe it's maybe Barry's super nice. So it's typical that like in almost all the trajectories. Yeah, I mean a measure. Yeah. Some sort of measure.
Oh, really? Oh,
Like a mathematical measure over that chunk of
I
phase
had thought
space.
that typicality in the sense of set theoretic. No.
Yeah, so I think there are a bunch of different ways to to quantify the sizes of sets. There are measure theoretic ways. There are also cardinality theoretic ways. There are other ways.
And they don't go together as far as I know.
They don't go together.
And now you can create paradoxes of things that are large but measure zero.
Oh yeah, they do. They will disagree.
But
Yeah.
I'm just saying that you want to you in your idea this nearly as big is a sense of I have a measure.
Yeah. Not always, but for this example, because in statistical mechanics, you usually have some sort of measure like a Lebesgue-ish, like a modified Lebesgue measure that's you're using to see how big certain subsets of certain energy levels in phase space are. That's the idea.
Okay, add that. We have 3 participants
Oh,
raising their hands.
all right.
It's a question for you whether or not you want to take their question.
Yeah, I'm happy to take questions now.
Okay,
Yeah.
so I think Tim, I actually didn't keep track. I think maybe we can go start with Tim and then Diego and then Jens.
Yeah.
Okay.
Okay, can you give me a little, I've gotten a little lost in the problematic here, so.
Oh.
Yeah, I think we're, sorry, Tim, let's, would this work? Tim, sorry, can you speak again?
Okay, can you hear me?
Yeah.
That's okay. So I'm a little lost in the problematic here as regards typicality. We all know we have to take total evidence to form a rational belief. And let's suppose I have a really, really biased coin, so it typically comes heads in your sense. But also God tells me next time it's going to come tails. And then I say, well, typically a coin that is flipped and that God tells me comes tails, right? That's just, I have, I have to take all the evidence that I have into account. Then you're not really defeating the principle at all. It's just the principle says, take everything you know into account, and what's left over, if something's typical but it's not settled, then believe that what's typical will occur. That just seems like a kind of much more straightforward way to deal with this, and I'm not sure why we're getting into this complication.
Yeah, good. So you changed the example there. So we started with one proposition. I can't remember what it was. I'm sorry. The coin will land heads, or what was it?
I changed it because I wanted things that are typical, and the coin doesn't typically land either heads or tails. So I can't even apply typicality analysis to that.
Sorry,
I can
could you say
apply
that
it to a
again?
long sequence.
Sorry, Tim, can you say it again?
Sorry, I changed it because a single coin does not typically come, fair coin does not typically come heads or typically
Good.
come tails. So I changed it to a bias coin, so I had two typicality claims rather than probability claims.
Good. So you're saying you've got a biased coin. Typically the proposition is typically the coin lands heads or something. Okay. And then you point out, so I haven't gotten to the principle yet, but you're correctly anticipating what the principle is going to say is, if God comes and tells you what's going to happen on this coin flip, you now have inadmissible information. So the typical principle, as I'm calling it, no longer applies to the situation. And then you're saying, yeah, but who cares? Because look at this other proposition. The coin lands heads, and God told me the coin lands heads. Was that the other proposition? And that is typical.
I'm not saying the principle, I'm saying the principle has a requirement of total evidence in it from the beginning.
Yeah.
And so it's not that you defeat it, you just always have to apply, we know you always have to apply a principle of total evidence to make to form rational beliefs.
Of course, yeah. You're though sticking the total evidence in the argument of tip. That's the sense in which I was saying you're changing the example.
Yeah, you also know that God made a prediction.
Yeah. So you're saying your principle would be something like, the thing that you're believing, this is helpful. This is helping me understand your expect the typical principle. Your principle is saying something like, there are going to be some things that are typical, but you should only, the only propositions whose typicality should lead you to expect the proposition are propositions that include your total evidence as a part. Good. Yeah, that's cool. Okay, so my principle is also going to have a total evidence requirement, not in the same way. But thanks. That helps me with your principle. I also just think that's an interesting principle. Yeah, like a follow-up question that I would just need to think more about is, how does that relate to the principle I'm going to propose? But yeah, I like that principle, and I like that it very concisely incorporates this total evidence requirement right into it. So that's cool. Thanks.
Isaac, isn't there an analogous conditional on the conditional chance being such and such, and you having the
Yeah.
condition of your evidence, you should have it.
Yeah, I think that's right. Yeah. Yeah, so there I'm going to focus on the principle, the original version, but then there are these things that are these conditional versions, like due to Hall. And yeah, this is good. Like, another question this is raising for me is, I mean, so I know that I can derive Hall's version of the principle, a big chunk of Hall's version of the principle from the typical principle I'm about to propose. Question that you're raising, well, yeah, but could I change to its like a kind of a typical principle that's more similar in form to Hall's principle that involves some sort of conditionalizing? And actually, maybe that would be Tim's, because
So that's the version of the principle that I like.
yeah, the conditional one. Yeah. Oh, no, yeah. No, I was just saying what would be the closest typical thing, and then I was thinking maybe that's what Tim was saying. Yeah. Well, it's not. It can't be completely analogous because the completely analogous thing formally would be like a conditional typicality operator, which takes in two propositions and gives you something. Yeah, okay, maybe I haven't. Yeah, okay, yeah. I don't know of a formalism for something like that, but I bet I could. No, I could totally see how to do it with my. Yeah, I could just invent that one. Yeah, well, I was just curious, how would you, but it would be super straightforward. So sorry for people, I'm not explaining well. So underlying the formalism that I've been using here is a particular semantics for typicality talk that is in a paper that Harry and I wrote up a while ago. The semantics is based on modal logic, and you can propose a proof system that is sound, and then we didn't prove completeness. I should say I didn't prove completeness. This was my part of the paper, so I shouldn't put that on Harry. But anyway, it's a nice system, and what I was saying to Barry just now was there is I can think of a natural way to adapt the system so that you have a typicality operator that is an analog of a conditional probability that would just involve a couple like measure theoretic tricks, but it would be, I think, pretty straightforward.
Do you want to continue taking questions?
Yeah, let's take these next two and then I'll go back.
Okay, I think that's it, Diego.
Yeah, I guess I'm just struggling to understand how the admissibility condition works to exclude like propositions that shouldn't be admissible intuitively. So let's say we've got the coin example, and I take the disjunctions of all histories in which the coin lands heads or something like that. So like that proposition actually like determines that the coin will land heads. So is that like inadmissible? And if it is, then why? Why is it inadmissible? Or if it's not inadmissible, like I guess it was my intuition that it should be inadmissible. So yeah, I guess I don't get like the condition.
Yeah, that's good. Right. So I think that is going to come out as inadmissible because I'm thinking of that disjunction as kind of the equivalent of God telling you the coin lands heads. And so that's how it's supposed to be inadmissible. But yeah, you're right. Like this is not if you put that disjunction in for Q and conjoin it with, well, okay, right. So I'm going to give you an example later on of something very much like this. So maybe I should try to give an answer to your question then, but just to be quick right now, I think that's a good point. It comes down to both the way that Q and P are actually formulated. It like depends pretty sensitively on that, and that might be a bad feature of this account of admissibility. That it is going to end up depending on things like if you take, the gas to be a definite description that kind of, has a different denotation in each world, in each micro state. In situations, if that's how you're reading it, then the tip subgamma of P thing in your example, I think is not going to count as a law. And so the Q conjoined with that is not going to be equivalent to a big disjunction of law history propositions. But sorry, that's a very high, like a very general response that's not getting into the details of what you're saying. So maybe I should try to come back to this when I talk about the problem. But yeah, thanks.
Okay, last, yes.
Yeah, my question was basically, I think, in the very similar spirit as Diego's. I was wondering how your principle handles cases where Q is, say, the proposition that the actual history is extremely anti-thermodynamic and gases don't typically, or gases, as a matter of fact, don't usually expand quickly. But that seems to be compatible with the claim that it's typical in gamma, in the whole state space, that gases expand quickly. And it seems, and the conjunction of this Q and the typicality effect seems to be logically equivalent to a disjunction of law history proposition. So yeah.
Yeah, good. So this is literally the exact example I'm going to use that's drawn from Ufink. And yes, so I think the way, and this is getting a bit more into the weeds, basically the way I think that gets, that this definition of admissibility renders that evidence inadmissible with respect to that proposition is you used an indexical in your formulation of that proposition, the actual, or an indexical like expression, the actual, trajectory. And that's going beyond what the laws say, because the laws don't tell you what is and isn't actual. They just tell you that, they just tell you how things evolve for each possibility. But let me come back to that because yeah, I think these are the sorts of cases that would suggest that I've picked the wrong definition of admissibility from the literature to adapt to this case. So, yeah.
Yeah, just to flag, I would be curious how one can avoid any sort of indexicals in a common or garden evidence, like, the gas that's in front of me, etc. But yeah, I'm gonna keep that for.
Yeah, but then I think if you do it without an indexical, then it is an admissible proposition, but then I think the principle gives the right result, because yes, think of it like this: you name all the trajectories, and you're saying, yeah, but take the proposition that basically says, like, let X be the trajectory that's going to actually occur, but just use X a name, not an indexical when you formulate the proposition, not X, basically. And that's that's typically true. That's true at almost all the worlds in the set of possibilities. And my typical principle says it is, therefore, it's rational to believe that the actual gas's trajectory is going to be one of those. And I just think that's the right result. It is rational to believe that the gas, because that's almost all the gases. It's only irrational as soon as you say, yeah, but that's the equivalent to saying that the gas is following a non-actual trajectory. And it would be irrational to think that the actual gas follows a non-actual trajectory. And then to that I say, yeah, I agree. But now you've switched the proposition. Now you're describing things using an indexical, and now you're going beyond what the laws and the history say. Okay, we'll do this all again in a few minutes, but that is actually that whole section. Okay, so you did it. Everyone figured out the next few slides. So here's the typical principle formulated in this way. So you've got an agent A, they've got some total evidence E, and suppose that total evidence is admissible with respect to tip P and also includes tip P, like you also just know that P is typical. And this is the part that I was wondering, a question about Tim's proposal, open question, like, is there some like very intuitive principle that says this happens if and only if some sort of fact about, tip P and E. But anyway, for a typical principle, A's total evidence E is admissible with respect to tip P and also includes tip P. Then in order to be rational, A should believe that P is 2, where P is any proposition. And as I formulated it here, gamma is the set of physically possible worlds. In some other work, I talk about some complications that arise if you let gamma be any set whatsoever. You can construct really stupid candidate gammas that give really bizarre results, and those conjoined with this principle would require you to have really bizarre beliefs. And so I think that only certain gammas can be used in this principle. I don't know which gammas can exactly, but I know at least one that there's one that I'm quite confident can, and it's this one, the set of physically possible worlds, the worlds picked out by the laws. Okay, so example, let tip sub gamma P be the fact that typically, so in the set of all physically possible trajectories, the gas quickly evolves to equilibrium. Got the statistical mechanist, or what the term is, Amber, and Amber's total evidence is the following conjunction. tip sub gamma of P conjoined with the proposition that the gas began in a certain macro state, which, as I was sort of alluding to earlier, is equivalent to a big disjunction of the gas began in this microstate or this one or this one or this one. So the conjunction of tip P with that proposition about initial macro states is going to be logically equivalent to a big disjunction of law history conjunctions. So Amber's total evidence is admissible with respect to this typicality fact. And so by the typical principle, Amber should believe that the gas will evolve to equilibrium quickly. Okay, so just gonna look at the time here. Okay, we're doing all right. Especially because I can go faster on this part. So, okay. So here's a simple principle that sometimes gets thrown around in the literature, and it's kind of related to something that we've talked a lot about in this seminar, Cournot's principle. Suppose that you've got an agent A, and they know that P is typical in the set gamma. Simple principle says, then A should believe that P is true. In other words, from the mere fact that something is typical, you should believe in that something. Okay. And this runs into some pretty straightforward problems of the kinds that people have been alluding to. The problem is that some propositions are typically true, and yet agents are not rationally required to believe those propositions. In fact, in some cases, there are propositions that are typically true, but agents are rationally required to believe that those propositions don't occur. So, and this is getting to what Jens was saying. This is a paradigmatic example. So the following example is based on some stuff that Ufink said in a paper a while, or like a big publication a while ago. So let P be the proposition that the gas follows some non-actual trajectory. Then P is typical in gamma, because nearly all trajectories are non-actual. In fact, all of them are, except for the actual one. So according to the simple principle, Amber should believe P. She should believe that the gas follows a non-actual trajectory. But that's false. It would be irrational for Amber to believe that the gas will follow a trajectory other than the actual one. That would be irrational. So the typical principle does not have that bad implication that the simple principle had. For let Q be the proposition that whichever trajectory the gas follows is the gas's actual trajectory. Q is obviously part of Amber's total evidence. It's just kind of the definition of the gas's actual trajectory is the trajectory that the gas follows. And Q is inadmissible with respect to tip P. And the reason it's inadmissible in this case, and I'll pause after this, and Jens, you can maybe say your question again, or if you don't want to, that's totally fine, obviously. But the reason Q is inadmissible, I'm thinking, is tip sub gamma P and Q, they both are invoking things that, like, the laws and the descriptions of the world do not invoke. Claims about what's actual. Which trajectory is the actual trajectory. The laws, or at least on most conceptions of the laws don't say that. They just say, here are the possible trajectories, here's what happens with them. And of course, by doing experiments, we can sort of zero in on which trajectory is the actual one, but that's not part of the laws. That's just kind of which trajectory is actual was a contingent feature of reality, not a nomological feature. And so propositions like Q, and in fact, indeed, propositions like tip sub gamma P are just not going to end, they're not going to be equivalent to disjunctions of laws and histories. And so Q is going to be inadmissible with respect to tip P. And so the typical principle just isn't going to apply in this case. Okay, let me just pause there.
Just say, I think my example was not that one. It also involved actually, but not in the way that this example.
Sorry, Jens, are you speaking?
Sorry, Jens, just a sec. Sorry, Glenn had something. What was it?
Oh, I was just saying, what you've written there about Q is this proposition.
Yeah.
It sounds like the proposition is that A equals A.
Yeah, it does kind of sound it.
What is the proposition?
The proposition is the trajectory that the gas.
False there? Is there something that might be false?
No, it can't be false. It's kind of a.
So it's just
Yeah, but it's a tautology that is expressed using a linguistic resource that isn't there in like first order logic, an actuality operator. Yeah. But it is a tautology in that you know,
So it's not a proposition.
you could express
Proposition
propositions.
is expressed as is necessarily true.
Yeah, right. But it's still a
itself,
proposition.
The sentence itself, its meaning is not tautological.
Yeah, I guess I think that's right. Yeah. Yeah. It's like
I guess I will not understand this.
it's like,
I am here now.
yeah, I am here now. That's a proposition, but it's necessarily true. Every time you utter it, you are here now. And it's the same kind of thing as going on with this word actually. Okay, Jens, go ahead.
I was just saying this is not the example I had in mind. I formulated my example with an actuality operator, but that was a defeasible feature. My question was just let Q be a proposition of the following form: most gases don't expand quickly. Which is much more in line with the Rory Diego had, I think. But I don't know whether we want to discuss it now or maybe in Q&A later.
Well, that can't be part of her evidence because I think evidence is factive and that's false.
But in a world, but you think in a world where most gases don't expand quickly and do you think the laws are different in such a world? That's maybe what's going on. You think like the past hypothesis doesn't hold and the past hypothesis is a law. Do you think like the typicality effects are different?
Good. No, that's not what I'm thinking. But what I'm thinking is you're thinking about what's typical within a world. And that's not the notion of typicality that I'm talking about. I'm talking about what's typical across all worlds.
Yeah, I don't mean that notion either. I mean, but anyway.
But you said something like in the world, the gases all are anti-entropic.
Yeah, let Q be the proposition most gases don't expand quickly. That's compatible with typ sub gamma that's logically compatible with gases typically expand quickly, as you say, because gamma here is the whole phase space, and I'm just picking out some trajectories in that phase space, but then conditionalizing on the conjunction of Q and i.e. most gases don't expand quickly, and it's typical that gases expand quickly. Conjoining on this, it seems to me I shouldn't believe that some gas in front of me is going to expand quickly. Rather, I should go with I should disregard the typicality fact and go with Q, which would be a counterexample. Or if Q is admissible, that would be a counterexample to the typical principle.
Yeah, and I still don't understand because the Q you said there, if I followed, is false. So it's just false that typically most gases don't expand, because go to each trajectory look at all the trajectories. In the vast majority of them, the gases do expand. So can you explain to me what the idea is?
Yeah, the proposition is just most gases don't expand quickly. That I don't use typically here just a proposition. Suppose an agent had that as evidence. There's a possible world at which those worlds exist, and that those worlds, it's also the case that typically sub gamma, the whole phase space, gases expand quickly. I just such an agent who has the evidence, I'm imagining here a world where God whispers in your ear that you're in an anti-thermodynamic world, but the typicality effects are just the same as in this world, because typicality effects are about the whole phase space.
That's why I was initially interpreting you as saying something about what's typical within a world. And then that's why I was saying okay, but let me bracket that, because then you said that wasn't what you were saying. If when you say most gases and you're using your quantifier most, are those
I could even say maybe
quantifying?
all gases
Okay, all gases don't expand.
don't expand.
So in the example I have in mind, we've got one gas, and the possible worlds are just all the possible trajectories of that gas. And so when you say all gases don't expand, I'm thinking that's false. Because here's how you evaluate it. You go to each world and see, does that gas expand? And then the vast majority of them do. But what I think what you're trying to say is what you're trying to say is within each world.
But that's how quantifiers work, right? I mean, they are world restricted.
Right. So my typicality operator, I mean, no, not always. And in fact, my typicality operator is a case where you're not working with a world restricted type of quantifier. Your quantifier is actually saying something about most, where the most is talking about all the trajectories. And then you were talking about specific trajectories. And what you were saying is equivalent to something like a proposition that says, the gas behaves anti-entropically or something like that. So the gas doesn't expand. And you're right, that's going to pick out that there is a proposition somewhere here. We're kind of, I think, talking past each other with respect to how we express that proposition. But we can at least agree there is a proposition here that can be expressed that is, going to be equivalent to the disjunction the gas is in anti-entropic microstate A or anti-entropic microstate B, and so on. And we also both agree that that could be within your evidence. Okay, so we agree on that. Can you now?
When we are at the world, when we are now imagining a world where it's just one gas, and so all the quantifier all gases just refers to this. Anyway, maybe I feel like maybe I don't want to keep this up.
Okay.
Okay. Yeah. Let's go back after.
Okay. Thanks. Okay. Maybe I'll go on. Or
yeah.
Did you have a question?
No.
Okay. So the last thing I wanted to mention, and in some ways, I think this is like one of the niftier features of the typical principle, is that it can be used to derive a very large swath of the verdicts of the principal. And in my mind, that is the feasible evidence for thinking that the typical principle is the more fundamental principle of rationality. I can even imagine arguments to the effect that would go like this: any chunk of the principle that isn't derived from the typical principle is a bad chunk. It's like a guide to rationality that's false. Again, some of the people on this talk have said things that I think would lead to that conclusion. And I am very sympathetic to that line, but I'm not going to argue for that here. I'm just wanted to present to you that there is this nice cute little derivation. Okay. So I picked this principle because it's, one of the most familiar. So this version of the principle says that your conditional initial credence in a proposition, conditional on your total evidence and some fact about the chance of that proposition at some time, should equal that chance. That's basically what it says. Here's how the typical principle implies a big chunk of that. Take any proposition that ascribes a chance to another proposition at a time. And suppose that this chance proposition typically obtains in the set of all physically possible worlds. And indeed, this is the case in the sorts of scientific theories that we're interested in here. Statistical mechanics, quantum mechanics, places where typicality shows up, and places where the theory in question appears to be talking about chance. It is often the case that many propositions of interest, scientifically, physically, the chance of that proposition equals X. That chance fact is true at nearly all the worlds in question. Then given two very standard in the literature views about how rational beliefs and rational credences relate, the verdicts of the principle regarding this chance proposition just follow directly from the principle. The certain plausible principles of rationality are just things like they have to do with like if you have a rational belief about a certain chance, then you should have a certain corresponding rational credence. Standard versions of what's called the Lockean thesis of belief are going to imply that. The second plausible principle is an updating principle. So your credences at later times or your credences at earlier times, conditional on what you learned in the interim. Also endorsed quite widely in the literature. Anyway, really interesting phenomenon. Those two pretty popular principles imply that if a chance proposition is typically true, then given the typical principle, the principle follows for that particular chance proposition. And that's what I mean when I say that the typical principle implies a lot of the verdicts of the principle, a large swath of the rationality space that the principle covers follows from just the typical principle, along with these other two sort of standard principles about, one, the relationship between rational belief and rational credence, and two, how updating should work rationally. So tentative thought to just throw out there. I've derived the principle, a big chunk of the principle from the typical principle. You can look at the derivation and see kind of which conditionals you would have to flip to get the derivation to go the other way. And there's one in particular that flipping would look totally insane. It's at one point I use something like, if it's rational to believe something about a chance, you should have a certain corresponding credence. The flip of that, to try to derive a big chunk of the typical principle from the principle would look like this. If you have a certain credence, then there's got to be a chance, a certain sort of objective chance associated with it. And basically, unless you're Barry, most people think that there are plenty of rational credences that aren't underwritten by any chances. Credences about mathematics, credences about
that extreme.
Oh, okay. I take it back. So not even Barry thinks that there are chances for every credence. So yeah, the reverse derivation is just based on completely implausible rationality principles. So interesting upshot is the following. Suppose there are no other good derivations of a big chunk of the typical principle from the principle. So you can imply a big chunk of the principle from the typical principle. You can derive a big chunk, from the typical principle, not the other way around. Then to me, that really strongly suggests that the typical principle is the more basic principle that governs rational stochastic states. That's the thing we're using sort of fundamentally when we set our beliefs and our expectations. That's our guide. It's not the principle, or if it is, it's only the principle by way of this more fundamental fact about rationality, the fact that the typical principle embodies. Having said that, I think there are some significant differences between the typical principle and the principle. And in closing, I just wanted to summarize what those are. The idea here being, look, maybe even if I've given some suggestive reasons for thinking that the typical principle is more fundamental, and so rational reasoning on the basis of typicality is more fundamental than rational reasoning on the basis of chance, there might be good reason to be wary of sort of drawing that conclusion to full generality. There might be reason to think, actually, you need both rationality principles. So I'm going to close with some on this more conciliatory note. So here are three differences between the typical principle and the principle to really sort of show that these are very different sorts of principles of rationality. First, the typical principle is about rational belief, the principle is about rational credence. Belief and credence are very different. Belief is all or nothing. Credences come in degrees. I mean, some people think there are no credences. Some people think that at least the state of having a rational credence is different from the state of having a rational belief. So for all these sorts of reasons, the principles in question here are different because they're about the rationality of different doxastic states. Okay, second difference. The typical principle is about typicality facts, or it uses typicality facts as a guide to what's rational. And the principle just doesn't. It uses chance facts as a guide to what's rational. Chance and typicality are distinct. There are formal differences. So I've argued, for example, that typicality measures need not be upward continuous, whereas probability measures just sort of by definition always are. Typicality, the notion of typicality is more general. It admits of many more different formalizations. This is something, Robin, you were bringing up earlier. You know, cardinality can be used to quantify typicality, not really so for probability. There are also explanatory differences. Typicality facts and probability facts figure in different sorts of explanations. So anyway, for a lot of reasons that I'm happy to go over more in Q&A if you want to hear it, typicality facts and probability facts are distinct. So the typical principle and the principle are sort of articulating constraints on rationality using different portions of the world. Typicality facts on the one hand, chance facts on the other. Okay, and then finally, each of these principles, each of these principles implies verdicts that the other does not. So the typical principle implies verdicts that the principle does not. Here's an example, just things that are typical, but that don't have anything to do with chance. The typical principle is going to tell you how to set your rational doxastic states on those things. The principle, excuse me, is just going to fall silent on that. A thing that the principle implies that the typical principle does not. If you've got a one-off chance, so, you know, chance is something that's just going to happen once, the principle doesn't care. It says you still got to set your credences equal to that chance, conditional credences. Certain conditional credences are constrained by that chance. The typical principle says nothing about this. Now, I actually think that silence is a good thing. I've been alluding to this a few times because I think if you've got a chance fact that, for example, occurs atypically, it is strange to think that sort of chance fact should guide rational doxastic states. I don't really know. I'm not settled on this. I'm interested to hear what people in the audience think about this. Yeah.
Can you clarify that by giving us an example?
Yeah, good.
Chance fact that is one off and one that is not one off.
Yeah, so like a non-one-off chance fact would just be anything that's repeatable, that, like, you know, rolling a die a bunch of times. A one-off chance fact would be something like, what would be a good example? Just like, suppose there were some type of atom, element that were invented only once, so it only ever existed once. And suppose you thought it was a law of nature that this thing decays in some amount of time with some chance. So then there would be a chance fact here. It's describing a single case event. And the principle says, great, so your credence in that event has to equal that chance, very roughly put. The typical principle would say nothing about this because this decay event is not typical.
So why do you think it's a good thing?
I mean, I'm still trying to figure this out. I'm not decided, but I think it's a good thing because it is weird. If you know that, so for example, if you know that it's atypical that this chance thing occurs, then it seems really rational for me to believe that you just shouldn't be setting credence. Like, you just should think, yeah, this isn't going to happen. Like, there is going to be no unobtainium or whatever the element is, because it's just completely typical that unobtainium doesn't exist. So it would be a bizarre sort of combination of doxastic states to think, you know, well, since unobtainium typically doesn't exist, I believe rationally that there is no unobtainium, but also I think the chance of the unobtainium element decaying.
The chance of it might come from a theory that itself encompasses a lot and so deriving from it to get the.
Yeah.
There's a certain chance and see if there's, that may give a good reason to believe that it'll gain a certain.
Yeah, so that I think that's fair. I think put it this way, whether or not whether single case events should be a guide to your credence is going to have a lot to do with what your account of chance is. And if you have a propensity account, I think it's much less plausible that they are a good guide to your credence than if you have a best system
Right, I
account.
think the right inference then is going the opposite direction.
What's sorry?
It's implausible. Propensity counts are implausible.
Right. So okay. So maybe from my example, you should just conclude I'm working with the wrong intuitive notion of chance. Yeah, that's fair. I don't want to put a lot of weight on that because yeah, I don't have a settled opinion on this.
I mean, this is a whole other discussion, but you can see that we see an account of chance. So that what you're saying just won't go through because
I'm not.
the chances come from the laws, which
Yeah.
are part of the best system decision of all the facts.
But suppose that you had a best system that was saying this on half the trajectories, there exists this process that has a chance. And then on the other half, the process just never, that type of thing just never happens. Question, what should your credence in that thing happening be? And I just think it's weird that the
Did it say
principle,
anything about chances? The best system, which is.
suppose this best system, yeah, the best system says on 50% of the trajectories, this process has this chance of happening.
If it be chances, it'll have to be more than just saying 50%. There'll have to be some sort of randomness about it.
Sure. Okay. So on 50% of the trajectories, this process, yeah, whatever. The point is just that, sorry. On 50% of the trajectories, there's this chance of something occurring. And then on 50% of the trajectories, there isn't. No chance is assigned to the thing. The laws have the form, if the world is one of the blue worlds, then here are the chances. If the world is one of the green worlds, then there are no chances. Now, suppose you're in a blue world. So there is a chance in your world. Principle says, because there is that chance, your conditional credence should be this.
Conditional third form of the principle. So one of it could be.
Okay, so yeah, so the conditional, I'm not seeing that that's going to matter, but okay, so let's.
Because what you should set your degree of belief by is the chance of whatever it is that you're talking about,
Yeah.
given that you're in a blue world.
I don't know if that's what that principle would say, because it's talking, that principle is about a conditional chance. It's not about the chance conditional on.
Maybe this is too much in the discussion, but I'm imagining that the best system is going to give us conditional chances.
I agree with that, but I'm saying, what if even those conditional chances are only occurring in the blue worlds? And then I'm saying the principle then tells you set your credences. If you happen to be in a blue world, you should be setting your credence. And then I'm saying, but you don't know you're in a blue world because half of them aren't. So it's a weird rationality requirement.
I have to think.
Okay. And then to make the example even worse, suppose it's not 50-50, suppose there's one blue world and you happen to be in it. Then principle says set your credence because the best system is assigning a chance to this one world for whatever reason. But then I think I'm sympathetic to the view, well, look, typically there are no chances. So you shouldn't be setting your credences equal to chances because you just, typically you're not in that world.
Let's go this
Okay, to be continued. Okay, so just to wrap up, thanks everyone. The typical principle says that if a proposition typically obtains, then so long as you have no evidence to the contrary, you should believe that proposition. Oops, sorry. So thank you, everyone.
Hey, thanks, Isaac.
Oh, Heather's got a question.
Oh, okay, yeah, you already got your question.
Could I ask you something?
Oh.
I kind of have to go after that.
Oh,
which is
okay,
why
sure.
I'm
Sorry. So
Sorry that I'm jumping the line here. I just wanted to ask you one thing, which is, this is going back to, when you define the tip function.
right,
Which,
right.
and then you said it's gonna be based on a measure, and that part you haven't really
I
elaborated.
didn't. Yeah, yeah.
I was wondering if that has to do with, in fact, the kind of credences or beliefs that you have then, because it seems like the fact that the tip gamma p thing is taken to be true is based on the measure that you specify.
Yes, yes. The truth conditions for tip P are going to be measure relative.
Right. And
Yeah.
then so there is that thing that you specified such that tip gamma p is true.
Yeah.
And it
That's right.
seems that then all of this has to be contingent on that specification somehow. Is either a
Yes.
sensible one, or maybe it has to also, if we were talking about the credence of the agent, then the agent's credence should also be, I guess, at least it should be able to go together with that, or maybe they even coincide in some cases.
So I'm not thinking that the typicality measure is kind of contingent on credences. I'm thinking there exists a measure that's the right measure to use
Okay.
for.
So would
Yeah.
the agent agree with that, or that's something that is beyond debate?
I think they'd agree if they know the facts about about the situation. I'm not sure I understand what you mean the
I
agent would
guess
agree.
what I'm saying is that to you, there is one true measure. The agent, well, there are two things. One is that the agent may not know what it is, so that they may not know whether tip gamma p is true. The also is the agent may or
That's
may
true.
not agree with it. So the agent's credence may or may not agree with that measure. That is nevertheless the true one. So it's the knowing and the agreeing
Okay.
from the agent's part.
It's not that there's one true measure for all typicality claims ever. There are
Okay.
just different. So in ever-writing quantum mechanics, there's one way to measure typicality. In Bohmian mechanics, there's another. In statistical mechanics, there's another. And these measures are different from one another. So the right typicality measure to give us semantics for that tip operator that I was talking about is going to vary from theory to theory. The theory gives it to you, I'm thinking.
Right.
An agent might not know that measure, and to me that's equivalent to we could have exactly this conversation about probability measures. You could be like, which probability measure is the right one to use? And then I would just say, well, the theory gives you a probability measure. And you could say, yeah, but what if the agent doesn't know it? It's like, yeah, then they don't know a part of the theory.
Well, I guess it does matter insofar as we do need to know whether tip gamma p is true or not.
Yes.
And so
Yes.
I don't need to know the full measure, just that it somehow would make tip gamma p true.
Oh, I see. You mean in the principle that I formulated? I see. Yeah, that's interesting. Okay, I see. So you're saying all I required was, you have to know tip gamma p, whatever the measure, tip gamma p
I
is
guess
a
so.
true, is a
Right,
fact.
right.
Yeah. Yeah. Okay. Thanks. That's helpful. I mean, I think that's okay. It's kind of like saying, I don't know what the right chance measure is, but whatever it is, chance of the coin landing heads is a half. So that chance fact constrains what the chance measures could be, but it doesn't fix it. I think that's okay.
Yeah, I think basically what I'm saying is because you require the tip gamma p to be part of the agent total evidence.
Right.
So the agent must know some things about this base measure.
Yeah.
Which could well be something that should also be part of the kind of credence that the agent must have.
Well, I was thinking in the sort of usual case, what they would know is they just know the typicality measure for the theory in question. So they know the Bohmian psi squared measure or whatever, or they know the modified Lebesgue measure. In the usual case.
It's still a theory. And
yeah.
It's something just hypothetical. Then how are they knowing it?
They just know that part of the theory like they know any theory. These are the equations of statistical mechanics.
Theories without necessarily knowing whether they're true.
Oh, sorry. So I'm using know as in this technical way that you can only know true things. You can't know something that's false.
Or you take it to be true, I suppose. right? You like, given that you believe the theory, this is
kind of the way statisticians think, I think. That we're sort of taking it to be true. We don't know it.
Oh, well,
Maybe
you
one of
could,
the pop-
yeah,
my theory is
that's,
that you don't, that, you know, nobody knows the quantum mechanics, it's some version of quantum mechanics.
Well, how do you know these things?
how do you know what? You just said you take it to be true, you don't know it. And I'm like, yeah, that's right.
That's the way people.
You're assuming that you know, you're taking it. For
Yeah.
granted that you know it.
Taking it for granted.
Or you assume
Yeah.
that.
Yeah, you're assuming.
Don't you know anything? What's something that you know? That's like a piece of a theory.
you're here now. Right, you know.
But it's like those
Well,
analogies.
What?
Generally, I don't, maybe I'm mistaken, but I don't think of the things I know as theories.
Okay, yeah. So, okay.
Theories, I think of as something that I don't know. that
They're
I
just
use,
open
that
to-
I
yeah.
experiment with. That's the way scientists think. I think.
That's fair. Yeah, I mean, I'm using,
So this notion that gamma p is something we know. This has me choose.
I think whenever you talk about knowledge, the context can become one where the standards for knowledge are insanely high. So it can become one where, in an epistemology class, all of a sudden you can't know anything because of certain kinds of ridiculous demon type scienarios. I was using a notion of knowledge does not come with nearly so high a standard. The sort of notion in which I would say, scientists know that the Higgs boson has approximately this mass. They
Okay, I
just
feel
know
bad
that.
because we actually have people in line.
Yeah, okay, yeah, sorry. We got away from
I have a
Heather.
lot of questions, but they have.
Yes.
I think
Ah.
Heather is,
Heather, yeah.
Heather, yeah, sorry, Heather.
My turn. Great. Yeah, thanks. So can you say a little bit something about like closure? So I'm thinking of like lottery paradox stuff, and you might have addressed this a bit with your X, but I'm thinking you shouldn't think X is typical microstate. So you shouldn't believe
Yeah.
it's X, but you also shouldn't believe Y or Z.
Yeah.
So then you put them together, and now what you thought you should believe because it was typical, was massive, could be any of them. You shouldn't believe by, adding them.
Yep. So I agree with all that. And a nice thing about the logic that I have for this operator is that it violates a kind of closure under conjunction. So A can be typical. It can be the case that A is typical, and it can be the case that B is typical, and yet it is not the case that A and B is typical. So it actually like sort of mimics the lottery standard, one of the standard solutions. Yeah.
Yeah, so I would have thought that was like one of the advantages of credences over belief, right? That you actually can combine them in this nice way. So one of the things that gets washed out with typicality is that it's either typical or not, right? So it has the more belief style characteristics. So I think I just missed it, but it would be interesting to see why, like, is there something analogous then to credence here where you can get exactly how much you should believe it or not? Or is this kind of running parallel still?
I wasn't sure about the washed out thing because, I mean, one of the standard lottery paradox solutions is using the fact that your credences and conjunctions are always lower than your credences and the conjuncts take it separately, and you get this lowering effect that then passes you under a threshold, right? And so it's actually the same sort of thing is going on with typicality.
Okay, yeah, so it is a kind of threshold view. I was thinking, giving up like belief and in exchange and accepting instead credence is like, I don't know, I think the right way to deal with lotteries, because you then get the right number for any of these conjunctions and it's not a mystery. I think the threshold is kind of counterintuitive, right? Like at some point you switch from belief to not, but it's just, so yours mirrors the threshold view. Is that what you're saying?
Yeah, sorry, yes, exactly. So it mirrors the threshold view while, right, I see what you're saying. So holding on to belief as a like perfectly good stochastic state. Yeah, that's right. Also, and you said something about like, is there a measure of like how much belief? Basically, no, that's what credences are for. And the thought is you could do this sort of trickery without that kind of stuff. Yeah, does that answer your question? Thanks. Jens, was it Jens? Yeah.
Yeah.
Yeah, I was also interested in the lottery paradox stuff, but I mean, that already answered everything I was wondering about. So I guess I can ask again about the earlier thing. I posted something in the chat, like if you could help me figure out where the argument fell. So yeah. I'm thinking let P be, if the past hypothesis is true, most gases expand quickly. That's typical if we assume Newtonian mechanics. It holds like an overwhelmingly most trajectories that obey Newtonian mechanics. Let Q be the past hypothesis is true and no gas expands quickly.
So that's the part
by
I
the
don't,
way,
I'm
most
not
gases,
following. Because that looks like that's just can't be the case. Like if the past hypothesis
no
is
gas.
true,
So these are world-bound quantifiers. I mean, there are worlds that are compatible with the past hypothesis, but that behave anti-thermodynamically. They're just extremely tiny measure in the past hypothesis. So I want to pick out those worlds. And similarly, most gases here in P, that's also a world quantifier. So it seems the conjunction of Q, and it's typical that P is equivalent to a history law conjunction. I basically pick out with the Q just the set of extremely anti-thermodynamic worlds that are still compatible with the past hypothesis. And so Q is admissible. And then by the typicality principle, someone who has Q and it's typical that P has evidence ought to believe that P. But Q implies that P is false.
yeah, I disagree with that. So Q you said was world bound, and P is not.
P is also world bound.
No,
P
not
is if the past hypothesis
typicality
true,
fact.
most gases expand.
No, yeah, my typicality operator is not a world bound operator. It's a
Yes,
it's an operator that says something about all the gases.
But the most quantifier in P, I don't mean the most quantifier in typical. P is the proposition. If the past hypothesis is true, most gases in this world intuitively expand quickly. And then typically P, that the truth conditions for that sentence involve quantifying over worlds. But so there are two mosts here, the most in P and the most in the truth conditions for typical.
Okay. Oops, sorry.
Yeah, and so the most in P is world bound. And in particular, Q entails that P is false. I can't, if you're talking right now, I can't.
Oh yeah, I'm just I'm trying to
just
simplify the example because I don't think you need all these mosts. I think you could just use the gas expands quickly and the gas does not expand quickly.
Yeah, but then it's awkward with the typical. It's typical that the gas expands quickly. It's, I don't know. Then you have to identify, if you name a particular gas, then you have to identify gases across worlds when you evaluate the typicality claim. But so just think of most gases as, just think the world just consists of a series of boxes with gases in them. And then you just say most of those boxes have gases that expand quickly. And that proposition will be true on overwhelmingly, or if the past hypothesis is true, then most of those gases, or most gases will expand quickly. That will be true on overwhelmingly most trajectories. And also something that, we can comfortably say, typically, I say here most because of course, even in the even the past hypothesis, even like thermodynamic worlds might allow for some freak gases which don't expand quickly. This is why I say most. But you might also, I don't know, if you don't know that, then you can say all. And yeah, anyway, just following the argument to its end, one ought to believe a contradiction.
Good. So, okay, I think I see now. So you've got, if the passive process is true, most, okay. So in nearly all of phase space, gas expansion, most of the gases expand. And you're saying, suppose you know that you're in one of the worlds where that doesn't happen.
Exactly.
So that's part of your evidence. Good, I got it. Got it. Okay. And then your concern is that conjunction is going to be equivalent to a disjunction of law history conjunction. So your evidence is going to come out as admissible.
Yeah.
Okay, I see. I was getting tripped up on the two kinds of mosts. Sorry.
Yeah, no problem. No problem.
Okay. So yeah, so is that going to be, yeah, that's interesting. So this is making me think maybe I need an amendment about the relationship between Q and P, and not just the relationship between Q and tip P. So you need something like P has to be compatible with your evidence. Because, and sort of the form of your point could be maybe construed as, look, tip P could be compatible with your evidence, even when P is not. Good. Yeah. Thanks.
I'm thinking, I mean, these kinds of trouble cases could be avoided if one took, if one relativized it to times and relativized admissibility to times. Because then, I mean, the kind of P that or the kind of Q that I'm envisioning here gives you kind of information about the thing that the typicality fact says. And in the formalism that you currently have, that can count as admissible, but we want a kind of, we want a situation where it's not admissible. Or we want a formalism that does allow for it.
Good. I like, so there are other examples like this, one of them is the one I thought you were talking about earlier, with the stuff about actuality. Or maybe it was Diego's example. So there are examples like that. Okay, yeah. That have made me want to add some sort of condition about how Q and P relate anyway. And so I think I would do that instead of the time index thing, but I haven't thought much about the indexing to time thing. So yeah, I'll have to think about that more. But thanks. Yeah, and sorry again. I do see what you're getting at now.
Hi, Isaac. Thank you for the nice talk. So I have a question, maybe not so relevant to philosophy, but relevant to typicality that you talk about. So I wonder if you know about the works in large deviation theory. So they also have quite a lot of overlap with statistical mechanics. But in those cases, the typical value of a system, and for example, a statistical mechanics system, the typical value of a physical observable is taken to be the most probable, in the sense the peak of its distribution. So that clearly is not the same as the typicality you are referring to. But in that case, what they are studying is precisely, because large deviation theory is precisely studying how the fluctuation goes around that peak. So if using the typicality that you are proposing, it seems too hard to, I just thought about the typicality over there, and I was wondering if there can be some connection to what you are talking about here. Thank you.
Yeah, thanks. I'm afraid I don't know enough about large deviation theory. It's a kind of, it's a science of like what I would call atypical behavior, right? Or is that wrong?
So for example, we know that statistical mechanics system, if you take the thermodynamic limit, so the observable will converge to a certain value. But so large deviation theorem is to study how it converges to that. But so in that sense, it takes the typical value to be the peak. So people are typically studying these like the difference between the typical value and the mean value. So the mean value would, so in thermodynamic limit that will coincide, but in approaching the thermodynamic limit so things will be different. So that's typically what they are.
Okay, yeah. This sounds, sorry, I wish I knew more about this to give a more
Okay.
interesting response. This sounds really interesting. I'll just say, I mean, it's tricky when you start talking about certain idealizations because those are often atypical, right? Like the thermodynamic limit is not a typical arrangement. It is sort of extremely atypical. And so it's not, in addition to just not being super familiar with this science, I also am just not sure that typicality would have much. I mean, what it would have.
Maybe if I put it another way, so your concept of typicality, would it be sort of can it be generalized to, for example, a continuum? So I guess if it's a continuum value, so you would take the typical to be a set that of almost measure one. But is there a possible way to generalize it to be more general than that? Your rationality, the connection between rationality and typicality, is there a possible way to generalize, not to say typicality is almost all possible worlds?
Is there another notion of typicality that still has to do with almost all, but then isn't possible world space? That's what you're asking?
Maybe not so strong as to almost all worlds, but still do the work of guiding. Guiding the rationale. Yeah, in that sense.
It's tricky because you know, sort of a concept that would be somewhere middling between being like almost all and half, say like, you know, the majority but not a super strong majority. Is that the same, is that a type of typicality? I think these basically the like cases I've been focusing on don't really say much about that, and kind of my inclination is to say I don't really know, like obviously certain kinds of middling value, you know, phenomena are treated well by probability. I guess I don't think of typicality as kind of about that. I guess I do just think of it as this like, there's a certain really robust kind of guidance to rationality that happens when the degree to which something is typical is like the exceptions are on the order of 1 out of 10 to the, you know, huge, like the exceptions are just so insanely tiny. Like there's a very special rational force that kind of a typicality effect has, and that's what I'm trying to capture with this typical.
I understand. So I guess the difference is probably, so you're talking about typicality in a really general way. So So every possible scenario are taken into account. And typically in certain sciences that so they are dealing with a typical like they're dealing with some restrained size of the measure of distribution so that they can take so with these constraints,
Yeah.
then the typicality can be more relaxed. But
yeah, that seems right.
Thank you.
Thanks. Thank you, everyone. That was really helpful. Thank you.